Hello everyone. Um, in this video, I'm going to resolve this problem. This problem is question number 2, part 1 of the RF homework assignments. So we are given a transmission line. The length is the quarter wave length, but the impedance here is 90 ohm. The reference impedance is 50 ohm. So obviously the transmission lines has different ohmic, different characteristic impedance. The characteristic impedance is different from the reference one. Then we are going to have reflection from the source and from the load. So assume that the load is a standard load with 50 ohm, and assume that the source impedance is a standard impedance of 50 ohm. So we have reflections in both the load and the source. Okay, so we are going to find the S parameter. So remember, when we are dealing with this kind of problem, we cannot base on the assumption that uh, there is no reflection at low, there is no reflection on the source. Okay, so we are going to stop. I'm going to show the screen to you. Okay. So to begin with, we need. I'm going to draw the diagram of this question. The diagram of the circuit for this question. So Z naught is the characteristic impedance here. Yeah, I will put Z here, 90 degree. So 90 ohm. And the length here is 0.25 lambda. And let's say this is port 2 and this is port 1. And we are going to have shown is a standalone 50. Yeah, because this is the question, what the question asks. So 50. Now based on the, so this is RL and this is RL source. Assuming that we are going to work out the refraction coefficient at the input and the refraction coefficient at the output. So let's remove this. Refraction coefficient at the output, refraction coefficient at the input. Yeah, so this is the thing we need to know. The reaction coefficient at the input is going to be the source. ROS, sorry, minus. So the characteristic impedance here is 90 minus 50. 90 plus 50. So from what we can get here, the value should be 2 divided by 7. And similarly, we can work out the same for the low. So 0 plus R, sorry, minus, I always make this mistake, minus, so also 90, 50, 2 over 7. Now, we are going to apply some formula for a transmission line like this. The S11 is going to be input and then 1 minus J2 beta L 1 minus and then overcooking. Okay, so in this case, we can substitute the value here. 2 over 7, 1 minus, okay, we need to work this out. So we have to work this out. E to the j and then 2 pi over lambda and then 0.25 lambda. And if you work out carefully, this one is going to be j minus pi, and this is going to be minus. So we just need to substitute the value. So minus 1, yeah, this guy is minus 1 according to here. Okay, yeah, we will let you see more clearly. Divided by 1 minus 2 over 7, 2 over 7, and then minus 1. So if you do it very carefully, uh, you will get 0.2583. So this is the answer for the S11, S21, sorry, S22, S22 first, S22. The formula will be simple, will be similar. And then 1 minus gamma in, gamma out multiplied together, and then 2 over 7, yeah, because this is what we have got, and 1 minus this guy also, yeah, this is from here, yeah, and then we can do the same. So if you get the two expressions are the same, so you will get this same magnitude, same answer for S11, S11 and S22 should be the same. Now, the S21, you need to use a better formula because the circuit here is basically passive. So in this case, S21 has to be equals to S12. S12, yeah? And then the formula is going to be the low and then the source. And then and then like this. And then beta L, yeah? This time beta L, not 2 beta L. Two beta L, yeah. So so if you do it carefully, 50, 50, and then 1 minus 2 over 7 square, and then this guy, you need to work it out. 2 pi, 2 pi over lambda, and then 0.25 lambda. So if you pay more attention to here, yeah, is equal to pi over 2. So if my understanding is correct, this is minus 3. Minus 3. So we can do this minus 3. And then 1 minus 2 over 7. 2 over 7 times together. And then minus 1. So if you work out more carefully, you will get minus 0.8491. So this is what you need. The S parameter for this box here is 0.2583, 0.5283, and here J 0.8491. Okay, so this is the answer of the question. This is the Hilton part 1. If you have further questions, please leave the question to the comment sections of this video. Okay, thank you. Bye bye.